Hey everybody, this is Larry. This is day 29 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Today I took the train back to New York, so I'm back in New York, of course. But yeah, what they say about there's apparently this thing called the marathon flu, where I mean it's not an actual flu, but basically for obvious reasons, probably your body's immune system is just it's not doing well because it's dealing with a lot of stress from the previous day or the previous whatever, right? So yes, I'm not feeling well today. I took a lot of naps, but so I'm going to delay so two things. Right? One is that I've been meaning to do the weekend contest. I still have not peaked yet. So hopefully that'll be fun. I'll probably put it on. I'll probably put it tomorrow. And then the other thing is that I'll do a marathon recap at some point, but maybe in the next couple of days. I do want to show you this shiny medal. Yay, it's me. Oh, it's my medal. Okay, it's a little bit awkward because it's actually very shiny, so you can see my laptop. But yeah, and it opens up apparently. But I opened it the wrong way. Okay, so I don't know. It's kind of cool. I don't know. I mean, at the end of the day, the only medal that matters is in my heart, right? So, it's fun. Okay, let's take a look at today's problem, and we also have the weekly premium challenge. So I'll try to do these. Honestly, still a little bit on the quicker side. I'll go back to our regularly scheduled in the future, hopefully. But for today, I'm probably just going to take a little bit low key and do this. Okay, let's take a look at today's problem first, and we have 2684, maximum number of moves in a grid. You give them a zero index grid. You can start at any cell in the first column, okay, and then traverse the grid in the following way. You could go to, so you always move in the column, and you could go up or down. So you're going from left to right, really, and you can only go bigger than the value of the current cell, strictly bigger, and you're just trying to return the maximum move. I mean, I think they're all variation of this, but I think it's similar to the one we had yesterday, I think. Okay, but this is, of course, in 2 dimensions. And the idea is just that for each cell, you store what is the, well, I think for this one, actually, even, you only have to store whether you can get to a cell, right? I mean, you can also, of course, if you really want to store the longest path that goes to a cell or that ends in a cell, but you can only start from the first column. And if you can visit a cell in the last column or in, say, column 3, that means that you only visited 3 columns and the maximum number of moves is going to be 3, right? So that's really, so you could, a very minor thing to look out for, but it doesn't actually matter that much, honestly. But sometimes, especially when you're in practice, when you're not lazy like I do get to tend to get to sometimes, you try to be as precise as you can, because for this problem it might not matter, but for another problem it might. Maybe you have to build on that realization so that you can take advantage of that. Not spending one more dimension, so then you can do another thing, right? So something like that, and it happens a lot. And honestly, I'm not always so good at these, but you try your best, right? All right, so let's so we can go through the columns, right, one at a time, and then we could go through the rows. The reason why I like to do column first on this one is because then now you can look at either the previous or the next, depending on how you want to push or pull your DP. But and you can probably actually even do a space optimization thing here, because you can already notice that column only depends on column, well, the other way around, but column only depends on column -1 and so forth, so you only need the last column in memory. I'm not going to do that because I can't think right now, honestly. But so these are just things you can do. So here we're going to set up the DP, and let's say DP of ij is equal to, and it's a little bit confusing because I wrote I here. Maybe I should just keep it consistent and keep this ji loop. But yeah, ij is equal to if we can reach cell ij, right? Something like that, right? And then of course we can always reach the first column, as they say, because that's the one that you could start from. Though I think I'm off by one here now that I'm looking at the examples here, because you make 3 moves, so it's the column -1 or something like that, right, in the number of moves. But of course it doesn't change what I said earlier, really. So yeah, so okay, so we want to say dp of I of 0 is equal to true, because that's just the first column things. And then now we start at from the first from the 0th column and the first column, say. English is hard. And then yeah, and this is just equal to so this is equal to true if dp of ij or I and j -1, right? If this is true, then we can reach here, or if dp of I -1 j -1, then we could also reach here, right? And of course here you have to make sure that I -1 is greater than or equal to 0, right? And then you can also do I +1 is coming from the previous one, right? And I want to also call out something real quick, is that I do no, this is right. I do realize that I kind of changed this from ij, say, to moving forwards to looking from what cell can go to the cell, right? And what I mean by this is that I'm going to actually bring up the paintbrush real quickly. Give me a second. This is kind of I mean, it's not a critical point for this particular problem, but it's definitely something that can easily be missed if you're not paying attention in an observation. And honestly, when I was younger, when I was more beginner, I think it's not something that I appreciated until I got really deep into DP. But let's say, you know, you have a lot of cells, right? This is terrible, I could have done something else. But anyway, but the thing is that they say that for a cell, actually let me change the color real quick. It's on the screen, right? Okay, yeah. Just want to make sure, otherwise sometimes I forget to take things on and off the screen, as you know. But yeah, let's say for a cell, we're saying that we can go up to the right or down, right? So that's thing. And of course, but what I actually wrote is that for a given cell, we can reach it from the previous these things, right? Of course, you can kind of make some argument or whatever, but it is a key thing to note that for this particular problem, this is true that this is, I wouldn't even call it symmetry, but it is just true that this is this way, because you can kind of prove this by whatever, right? But I would also say that you have to be careful, right? You have to be, and what I mean by that is that this is not always like a easy thing to make, right? Because for example, let's say if our green cell, which is the problem described, if let's say this does not exist, right? If this does not exist, then here the red thing, you do not actually remove this one, right? It may be tempting to kind of write it that way, but actually you remove this one. Why is that? Well, you just have to write out the green things, right? Because if you write out the green things, then let's say you have this cell here, then it goes here, and the next cell here, and then you have this other cell here, and then you goes here, and then these two cells are the cells that goes into red, right? So there's some subtle things, and for this one, it's easy to kind of like not think about it and skip ahead. But I just want to point it out because for some problems it will matter, and there's some stuff about symmetry and stuff that I'm not going to get into today. But yeah. Anyway, and then now we could probably just go through the entire thing and then loop it, but we can even just do it here, right? So yeah, so best is equal to max best j if dpij, right? And that's pretty much it. It should be anyway, unless I'm wrong, then I'm sad. Oh no, wait, why did I misunderstand? Oh, I am just being dumb. This is saying that this is reachable. I don't know. I'm just being, I forgot the critical part of the increasing thing. All I did was saying that this is, because I was trying to explain this, but this is reachable, but it has to be that we don't even use grid at all, which is that the previous cell is strictly less than this cell, right? And of course we have to do it for the other ones as well. But with the correct index. Right. Oh, why didn't I meant to one. Oh, maybe I did. Okay. Yeah. What happened here? Oh, I plus 1 is whoa, not okay. I am apparently just rushing a little bit, but that's the general idea. Very easy to mix up R and C. That's why you should slow down, be careful. But I'm gonna blame it on the fact that I just ran a marathon. That's my story, and I'm sticking to it. Thank you. But that's all I have for today, though. Oh, actually, I lied. Let me go over the complexity really quickly. Of course, this is going to be linear time, linear space. Keeping in mind that linear in this case is R times C, which is the size of the input. The size of the input is R times C, and we have R times C space and R times C time, right? That part I'm not going to go into too much. But one thing I would say is that what is the one thing I would say? Oh yeah, as I said, you can do a space optimization based on the fact that everything only cares about j-1. But yeah, I'll leave it up for the programmers at home. My eyes are really tired. So that's all I have for today. Thanks for watching. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.